Hi folks, this is Karim Rao from IT Visualizer channel. We will continue our lab, the matrix lab. This is the video number 130. I've been discussing in the previous video the following. We are still working with troubleshooting Windows using a couple of tools called Microsoft Sysinternals suite. This contains a lot of useful tools we can use for different purposes. We have seen some of them are very useful as a remote tool to troubleshoot problems. Some of them are for gathering information like PS Info, PS Logged On utility, something for troubleshooting network problems like PS Ping. We will dedicate a video to discuss PS Ping. Anyway, you have seen how AI tools have explained the purpose of each tool. For more info, you can go to Microsoft website and see the description of each one of these tools. And actually, the part where AI tools exceed is in the part of giving scenarios. So, especially Claude 3.7 Sonnet, I have given him a couple of prompts to create scenarios. We can use Microsoft Sysinternals suites to solve them. We have seen that we have already one case before we have discussed in the previous video, and today we will discuss another case, and we can see another thing concerning those cases. We will see that they can be explained using an audio tool, something that you can generate. So I can generate like a podcast or an audio podcast to explain the case generated by Claude 3.7 Sonnet. Okay, so we have seen before how we can do that. We can go to Notebook LM, another AI tool by Google. You can go to it and tell it to generate an audio podcast from a pasted text. So I have gone to Claude 3.7 Sonnet case and copy it as text and put it in Notebook LM by Google and tell it to generate an audio podcast from this case. We have seen it is very useful. It is very humanic. You cannot feel any AI sound. They are two normal persons, a guy and the lady, talking to each other and discussing the script or discussing the case that we are working with and generated by Claude 3.7 Sonnet. We will go today and continue another case which called the Phantom Footprints Assess Internal Security Investigation. We have discussed a part of it in the previous video, but we will just revise it because just to refresh your minds. Here we have Security Center Operation Thursday, 3:30 p.m. The Security Operations Center, SOC at Meridian Financial Services, is a dimly lit room filled with large monitors displaying network traffic, system logs, and security dashboards. Elera Chen, a cybersecurity analyst with shoulder-length purple tinged hair and a collection of security conference badges hanging from her laptop bag, stares intentionally or internally at alerts flashing on her screen. Elera saying that there is something like a breach, mumbling to herself. A third anonymous authentication pattern this week, same time pattern, just different accounts. This is definitely not coincidental or not a coincidence. She picks up her phone and calls Theo Barnes, the company's senior system administrator. Theo, it's Elera. Can you come to my SOC? I've got something strange there that been bothering me for days, and I think we need your Windows expertise. Through phone, Theo lets me guess one of those weird authentication alerts. Yes, but I've spotted a new pattern now. This feels like a classic case of low and slow probing. I would bet my entire hot sauce collection that's something already inside our network. Uh, Theo sighs, be there in 5 minutes. I will bring my Sysinternal toolkit. 10 minutes later, Theo arrives with a laptop and a USB drive. He is a tall man with a meticulously trimmed beard, wearing a Star Trek uh, t-shirt under a blazer and carrying a mug that reads, "Have you tried looking at the logs?" So this is like a human description of the character, which make it more humanic or more human, and also the another description for Eleora. So these two normal persons have a problem what seems to be like a breach, but they do not identify, or they cannot identify it as a real breach. It's a pattern, and they are suspecting that it could be a breach. Sorry I'm late. Exchange server decided it need attention as always. So what we are looking at, points at her monitor, look at those authentication events, 3 different user accounts, all from accounting, showing successful logins at unusual hours between 2 and 4 a.m. Each user logged in once, then again 3 days later. So this is the pattern. A couple of users from one department showing unusual logins between 2 and 4, which is not working hours. They log once and then log successfully another time after 3 days. So here he is talking about the source is internal IP. So they are logging from, or these login events are from a source internal IP. So it's an internal workstation that these users log into. That's odd. You have confirmed with the users. All 3 swear they weren't accessing systems at those hours, and the login patterns don't match their work habits at all. Our SIM, this is the security, I think, analyzing or security and log analyzation system, flagged it, but there is no clear evidence of compromise, just their weird behavior. What does security team think? Ilera says they have swamped with the compliance uh, audit and suggested I keep an eye on it unless I have hard evidence. I need your help to find that evidence. So there is no evidence, just a pattern. They don't know, or they cannot have a clear evidence of hacking. There is no tools for hacking. There is no something suspicious. Only abnormal login on a PC. Okay, so they need to dig deeper. He will use the sysinternal suits to dig deeper in this situation. Theo sits down at an adjacent workstation. All right, let's make a systematic approach. First, let's identify the source machine for those connections. We need to see the IP address and see what machine this login events has been done on it. Then we need to examine that system for signs of compromise. So we need to go, this is the workstation, accounting WS42, which seems to be also some naming convention. This is an abbreviation of the department, and this is WS is for workstation, abbreviation for workstation. 42, maybe they have 42 workstations relating to accounting. Angela's workstation in account. I have already checked base logs, but nothing jumps out. We need to dive deeper. This is exactly what these internal tools were made for. Let's set up a remote access to that machine and start investigating. So here is our investigation environment. Theo and Ilera move to a quieter workspace where they can focus on their investigation, on the investigation. Before we connect to Angelica workstation, let's make sure we have our toolkit ready. I always keep an updated version of Sysinternals on this USB. But let's grab the latest from the Microsoft website to be sure. So he wants to make sure that all of his utilities are up to date, so he can get it from the live website of Microsoft. We have seen this in the previous video. I usually download the complete suite, but if you are doing incident response frequently, you should bookmark live.sysinternals.com. This is where we can get the latest tool and run it on the spot. You can run the tools directly from there without even downloading them. I have used some of these tools before, but I am more familiar with dedicated security tools. What's our approach here? For a potential compromise, we need a combination of tools. Process Explorer to see what's running, to make sure there is no malware infected the machine or some spy tools. Auto runs to find persistence mechanism. Okay, if it is persistent, maybe a malware that runs during the login of the user or the boot of the machine. Process monitor for real-time activity to make sure maybe there is still the tool is sending data outside, maybe, so we need to capture some real-time data for that. TCP view for network connections to make sure if this machine is connected to an external IP address, this is also an evidence of a hacking process. If we need to set up ongoing monitoring, so there is a tool, or there is a folder named Theo sets up a folder on the laptop, lab investigation, the machine with subfolders for different evidence types. Let's create a PowerShell script to help us collect evidence systematically so we can document everything properly. We have stopped the last time at this script. We will see it will do a lot of things. It will create a folder as an evidence. It will go and could create these subfolders in this folder, and then begin a couple of things. It will begin, let me see here, it will get the basic system information for this machine. Then it will go and export Windows event log. It will see the active network connections on this PC. I think it also will get the connections, the network, I think the network info, or the network connections that are established to this PC, which is good to make sure if there is any, or this PC is connected to an external IP source. Running processes, we need to have all of the processes running on this machine to make sure, or to analyze it to see if there is any abnormal task or any abnormal process running. Schedule task, we need to see if maybe the malware is making some schedule task to run or to reinfect the machine if we remove the original file. We have services, maybe there is a service that will be used to hack, and then these are all basic data, and then this is all done using command prompts. CS task, this is a command prompt. Task list is also command prompt. All of these are command prompts. EWEU, VTOL, utility. Okay, this is also command prompt. All of these are command prompts. Okay, and collecting data. Then we will go deeper by running sysinternal suites for deeper analyzation. Ensure we have psexec to run commands remotely. Here, ensure we have psexec to run commands remotely. Here he will have a script to make sure that he have already psexec, I think, on his IT workstation, not the remote machine, okay? So this will download the psexec automatically so he can use it. Then create a temporary directory on the remote machine. So I think this will be for the logs. So there is logs on the IT machine and logs on the remote machine, and then he will copy these logs from the machine here to his IT machine. So this is the thing, okay? Copy sysinternals tools to remote machine. I think this is not necessary, but anyway, let's go with it. Okay, he will copy them and go to the remote machine, and then run auto run, so he can run then auto run on the remote machine to see what are the auto run tasks or auto run processes on the machine of the accounting, and then we run TCP view to see the connections established to this machine. Basically, these are all deeper analyzation of the machine. We have Process Explorer, which what it will do, I think it will export. Let's see here, it will export except EOLA. So it will export all the processes on this machine, but maybe more details through Process Explorer, and then run handle another program from the sysinternal suites. This gives more details about each process and the DLL files, I think, related to this this process. Okay, so this is also another thing here, and also export it and then run list DLLs. So I think this is logically, so we know the handles to know the DLLs, and then we can list the DLLs and see if is any unassigned DLLs which maybe is a sign of hacking or an unverified DLL file. Okay, we will list them, we will know them, we will know which process has which DLLs, and then we will list all the DLLs for a certain handle maybe or a certain process, and then we will check all of the DLLs if they are signed or not through run sign check. I think this is it. Maybe check on suspicious locations. So here I think we can do something here very simple. We can get this script and ask Grok to give it a summary to see what it will do exactly. Okay, so most of things are capturing data, capture memory dumps of suspicious process if needed. This section would typically be used for initialization for pro dump or something here. PSExec except EOLA. So all of these are commands. Can we copy and ask Grok to explain it now? Let's see here the explanation. Impressive. This script will give us solid baseline of evidence to work with. How do you want to approach the actual investigation? Okay, so let's start by getting remote access to Angelica workstation. Since we are investigating to a potential security incident, we need to be careful not to tip off any malware that might be monitoring the system. Good point. We should also ensure we do not destroy any evidence. So this is very good for collecting evidence. But let me go to Grok and explain this script in layman terms. So let's see how we can what it does exactly. So let's see how we can explain this one. So we will do like that and do like this and tell him think, and let's do like that. And we can also tell him to simulate the output for this script. Okay, let me see the explanation. Okay, so imagine your computer may have been hacked. You need to figure out what happened. This script like a detective toolkit that automatically gather clues from the computer so you can investigate. It's called an incident response evidence collection script. It uses special tools called Sysinternal tools to collect information. Here is what it does step by step in plain language. What you tell the script: which computer to check, where to save the clues. Okay. Uh, If you do not pick a spot, it saves them to your desktop in a folder named with the computer name and the date and time. Very, very good explanation where the Sysinternal tools are. This is good. If you do not say, it looks for them in your desktop or tries to grab them from the internet. A good one. So if it is not on your laptop, the IT, it will go and download them. Set up your filing system. The script starts by creating a neat folder in your computer to store all evidence. Inside this main folder, it makes smaller folders like processes for info about running programs, network for internet connections, autoruns for stuff that start automatically, and more. Good thing. It also creates a file called case-notes.md. It's like a notebook where you can write down what you see and what you do and what you think about the situation. It's already set up with sections for you to fill. Okay, so that's good. Collecting basic computer information. Next, the script grabs some basic details about the computer. Sysinfo. It runs a command called sysinfo to get facts like the computer hardware, software version, and setup. This goes into a text file. Event logs. It copies the computer logs like a diary of what have been happening. For things like system events, app errors, and security alerts, they are saved as special files you can open later. Network connections. It uses netstat.ano-ano to list all active internet connections and what programs are using them. It can show if something weird is talking to the internet. That's what we're talking about. Running programs. It runs task list /v to list every program running on your computer with extra details like who is running it. Schedule tasks and services. Checks what tasks are set to run automatically and what are background services are active. Hackers sometimes hide stuff there. All this info gets saved into right folders inside the main evidence folder. Deeper. Steps 3. Deeper digger, or digging deeper with Sysinternal tools. Now the script uses some advanced tools, Sysinternals, to get more clues. Here is how it works. Getting the tools ready, it uses a tool called psexec to run commands on the computer being investigated, even if it is a different one from where you are running the script. So this is remotely. If the tools aren't on your computer, it grabs it from a website. This is it. It makes a temporary folder on the target computer and copies the tools there. So there is two tools. one on your PC and one on the other remote PC. Running the tools. Auto runs list everything set to start when the computer boots up. Hackers might sneak their program here. This gets saved as a spreadsheet. Okay, spreadsheet file. TCP view shows detailed info about network connections like netstat but fancier. Saved as CSV file. Process Explorer gives a deeper look at running programs. The script saves its info in a CSV file too. Handle shows what files or setting each program is touching. This can reveal what a bad program is up to, saved as text file. List DLL, list extra DLLs or extra files called DLLs that program use. It flags one that aren't signed, meaning that might not be legitimate. Saved as text file. Then sign check. Checks imported folders like system32 and users for files that aren't properly signed. This could mean tampering. Saved as CSV file. Very, very good. And then we have memory dumps. This is optional. There is part of the script. Turn it off, commented out, but could be used later. If you would like to grab memory of a suspicious program using proc dump for a super detailed look, you would need to know which program to target first. Okay. Step 4, cleaning up. After collecting everything, the script deletes the temporary folder it made on the target computer so it doesn't leave a mess. Step 5, finishing up. Finally, it tells you, done, all evidence saved into this location. Do not forget to write your notes in this MD file. So, in short, the script's like a super organized assistant for investigating a hacked computer. It collects all kinds of data like what's running, what's connecting to internet, and what starts automatically and puts it into a folder for you to look at. It uses both built-in Windows commands and special sysinternal tools to get the job done fast. Then it gives you a notebook to write down what you find and what to do next. This helps people figure out if something bad happened and how to fix it. So I think this is very, very good explanation. Now we can continue and see how this will go. So they will connect to Angelica PC using psexec to get a remote command shell. We'll use Process Explorer and Autoruns to get a snapshot of the current system state. Process Monitor will help us capture any suspicious real-time activity. We'll fire off Wireshark, so another program for capturing data on our monitoring S-PAN port to watch for any network traffic from the machine while you are investigating. If they're malware, it might try to phone home when it detects our activity. So we will run Wireshark on the machine. This will capture data in the wire. If this is something we can explain it in simple terms, let's see how this investigation will go. So now we go to Angelica. We will use psexec to connect to it using the system account and open a CMD. Now we are on Angelica system level access to the remote machine. Perfect. Now let's use Process Explorer to see what's currently running on the machine. He copies proc xp to the remote system and run it with the following command. So we will copy it. This is the copy parameter. This is the system parameter. We will copy it to the remote machine. Then Process Explorer launches displaying or running processes on Angelica workstation. Peering at the screen, let's look for any unusual things. So that means that I can run Process Explorer remotely and I can see it from my machine. I don't know if this can be the case or not. Let me try to see if this is possible. If we go there and open, is there a way that we can run Process Explorer remotely? So this is Sysinternals. We have PR. Is there a way that we can run it remotely? Maybe we can choose so this we can go and tell him run as a limited user, options, run at login. So view system information, process, find user on desktop, remote control. What is this one? Control to stop. Maybe this is the one, the remote control thread. So I think this is it. Maybe let me have just a little confirmation here. Let me ask Perplexity, which can be more accurate. Let me ask it a simple question. Can I use PS exec from my PC to open proc expert or process explorer on remote machine and see the data on my laptop or IT machine. Let's see if this can if this will help. This is Pro. Okay, and let's try this one. Yes, you can use PSExec to run process mode on a remote machine and view the data on your local machine. Here's how. So this is the Process Explorer. Let's see how this will be done. You will download both tools to the Sysinternals website. Okay, so that's good. Then, okay, so that's the same as what was said by Cloud 3.7 Sonnet. Once the Process Explorer opens on the remote machine, you will see its interface on your local machine. Now you can interact with it as if it were running locally. That's good. So this is good. So let me ask it a simple question. Can I do that with applications not from Sysinternals tools and adding, because I am just suspicious about if I open, for example, a setup program on my machine and a program that I need to set up remotely, but I need to open the interface on my machine and begin working, and this will be appearing to the user, but he is not interacting. I am the one interacting. Let's see how this will be. Interactive mode. Let's see if he can confirm that. Let's see how this will do. Basic to run application. Okay, let me see how this will do. Yes, you can use Basic to run application other than Sysinternals tools on a remote machine while enabling interactive mode. This allows you to interact with the application as if it were running locally. So that's what I'm talking about. So here we need to what we need to have administrative privileges. We need to have firewall, opening PSExec traffic, and remote registry service should be enabled. This is good because the program may need some changing in the registry. Okay, obtain PSExec, run the command, and then you put the application path. So that's the session ID, the user session. Okay, and then begin putting the information. Example, to open Notepad interactively on a remote machine. This is another good explanation. So we will open it remotely. The command starts Notepad in session 1 on the remote machine, allowing interaction. The I switch enable interactive mode, which allows GUI-based application to display their window On the remote machine desktop, you can specify session ID to target a specific user session. Notes and consideration. If no specified PCX defaults to session 0, which might not be interactive depending on the system, ensure that the user account control on the remote machine is configured to allow remote interactive process. For enhanced security, avoid bypassing passwords in plain text. Instead, we use secure credential management tools. Basic does not meet your needs. Consider alternative like PowerShell or RDP. Okay, so I can open Notepad remotely and I can interact with it. So the user can see if I open the Notepad remotely, I can open my Notepad here, type something, and it will appear as a Notepad on the other remote machine. This, I think, what I was talking about. We need to try that to see if this will work or not. Anyway, so let's continue with the case. I think yes, we can now continue. Now here I have opened a Process Explorer. Display or running process in Angelica workstation, peering at the screen. Okay, let's look for anything unusual, unexpected processes, a strange parent-to-child relationship, or unassigned executables. All of these are signs of hacking. Pointing the color coding in the Process Explorer helps identify different types of processes. Purple means that the process started since we launched Process Explorer. Blue processes are running uh, in the same user account as Process Explorer itself, which in the case is system. So this is a couple of things. We have purple, we have blue, and we have pink. Let me open it also to make it explained more further. So we have a couple of color codes. If we see here now, so for example, the blue is saying that the purple means this one, for example, purple means that uh, the process started since we launched Process Explorer. This was launched with the Process Explorer, okay, the purple one, okay, the purple one. As for the blue, okay, saying for the blue processes are running in the same user account as Process Explorer. So these are processes run under the user account. Where are the blue? So I think this is the blue. He's talking about the blue one. I think this is it. Can we get let me try to see if we can get the legend, so we can see here options, for example, configure colors. Let's see here. So we have here where is the blue one? Immersive processes, new objects, new processes, deleted processes, own processes. I think this is related to the user, the own process. Services, this programs related to service, suspended processes, packed images, reallocated DLL jobs. So the purple one is services, okay. We have other immersive processes and protective processes. So, okay, this seems to be fine. And the pink ones, these are package executables, which could be legitimate software using compression, but also can commonly be used by malware to evade detection. Theo sorts the processes by company name and start filtering out known good Microsoft processes. Okay, let's enable verify image signature from the options menu. This will show us which users are digitally signed. Let me see here, view. So here is talking about enabling options from the options menu. Let's see here, verify. Where is the verify one? Verify signatures. So I think it's flicker a little bit, but let's see here again how this will help. Where are or how this will appear here. So here is the column verified. So all of these are a good thing. This is a good indicator. So now we can see that they are verified. All of these programs are verified. Okay, all of these are verified. Okay, mostly by Microsoft. So now we can see who is not verified. This is a good thing actually. Now let's continue with the case. After enabling the option, several processes appear with unable to verify in the signature column. Okay, pointing what's that process? SV Ghost, but it's not running as a service account and it is unsigned like the legitimate Windows SV Ghost. So this is a process by Windows. Okay, uh, it's not verified, even though it's a Windows process, and it's not running as a service account. So I think it's SV Ghost. It is related to services. Maybe let's try to see. I think I have some SV Ghosts things here. If we go, so for example, we have some SV Ghost. Here you go. This is all of these are verified, as we can see here. This is a good thing. So we can see this is SV Ghost. Okay, and all of these we can see that they are running under certain services. Let's try to have a simple question. What is a Windows SV host? I think this is the one. svc host.exe. Explain in simple terms, and let's see how this will be explained. So we can see here that short for service host, it's a critical system process in Windows that help operating system manage and run various background services. So it is related to services, okay? So he's saying that it's not running a service, okay, and it's not signed. So this is strange. It is related to services. So here is an explanation. Okay, many Windows services are built as dynamic link libraries which cannot run on their own. The SV Ghost process acts as a host to load and execute these DLL-based services. Efficiency: instead of running each service as a separate process which could use more system resources, Windows groups related services together under different instances of SV Ghost. This reduces memory and CPU usage, like making the system more efficient. Let's see examples of service. Some common services managed by SBOS include Windows Update, Windows Firewall, Windows Network Management, and System Maintenance tasks. Okay, so backing up a couple of DLL files related to a certain service. Okay, multiple instances. It's normal to see SV Ghost process running in Task Manager. Each instance handles a specific group of services to ensure stability. So what we're talking about here, services. For example, if one service crashes, it won't affect unrelated services running under other instances. Is it safe? The legitimate SV Ghost is located in C Windows System 32 folder and is signed by Microsoft. However, malware can disguise itself using the same name but operate from a different location. Device authenticator, you can check if it's file path or digital signature. This is what we are doing currently in Task Manager. Okay, let me put it that way. Can you give an analogy to explain that? Just to make it more simple, let's see how he will do with this. Okay, let's see that. How SV Ghost. Apartment building analogy. Imagine a large apartment building which each apartment represents a large apartment building where each apartment represents a different Windows service like Windows Update, Windows Firewall, etc. Just as apartments need a building to house them, these services need a host to run them. Okay, SBOS is like the apartment building itself. It provides a structure where multiple services can reside and operate efficiently. Each instance of SBOS running on the system is like a separate wing or section of the building. Each wing houses a specific group of related services, apartments. Just as having multiple apartments in one building is more efficient than building separate houses for each apartment, SV Ghost allows multiple services to share resources and run under a single process, using overall system overhead. Benefits explained: efficiency, Just as the apartment building reduces the need for separate infrastructure for each apartment, SV Ghost reduces the need for each service to run as a separate process, saving system resources. Organization: the building SV Ghost organizes services into logical groups, making it easier to manage and maintain them. Stability: if one apartment services has issues, it wouldn't affect the entire building, the system. Just like how a problem in one instance is because wouldn't crash other unrelated services running under different instances. So I think this is good. So now we can continue with our scenario. So he has an instance of SV Ghost not running a service account. And look, it's parent process. It's running under Windows login.exe, but it doesn't appear to be a standard Windows component. So when login is in a certain location, but this seems to be, this file is not in a Windows folder maybe. So right click on the suspicious SV Ghost process and select properties. Let's try to imitate that. So for example, I have SV Ghost. Here you go. For example, let's do like that. Here, let me try to filter it. SVC host. So here, for example, we have one of them. Right click and properties. So here it will give us which service it is running. It is running NCB service. This is a service, something local system network restricted. So I think here we can get what service it is running. It is running something called NCB service. Okay, so and it is, let's see if it is verified or not. I think it is verified. We can see from outside. This is the parent. It's running services under system. Let's see. Look at the command line. It's running from a temp directory, not from system32. So this is a sign that it is not a Windows component. Now it is running from system32, so it is a good thing. Let's continue. Here we have it's temporary, where the legitimate SV host instance run from, and the strings in memory include what look like encoded PowerShell commands. Can we see the memory from here? Where is the memory? So I think here we cannot see the memory, but he can see the code, or we can see the command line. You can see performance, disk, and network, GPU services, threads. So okay, let's continue and see what he is saying. And the strings in memory include, so that's definitely suspicious. Let's check if it's maintaining any network connections. Theo switch to TCP IP tab in the process properties. So this is good. We can see here what IPs it is connecting to, which is very, very good. Okay, so this is one good thing here. What does that say? Interesting. It has established connection to an external IP on port 443. Let's make note of the IP address. Here you go. Typing this on her laptop. Let's check against our threat intelligence feeds. This IP isn't explicitly flagged, but it is hosted in a data center known to be used by several threat actors. Isn't explicitly flagged, but it is hosted in a data center known to be used by several threat actors. Let's look at the DLL this process has loaded. So we can switch to the, where is the DLL? So we can go to the image. Where is the DLL? We can see this from which one? See the strings? So let me see what he is talking about. We can go, he's saying that we can go to look at what the DLL this process has loaded. He switched to the DLL tab. Where is the DLL tab? We can see this is performance, this is graph, this is disk, graph, services, threads. So yeah, this is the DLL, TCP, we have security. No, I don't think so. Environment, job, strings. So I think this is the DLL. So for example, I stop in one of each one of this. I think we can see the DLLs from here. So this is how we can see the process and the DLLs related to it. So here is a special DLL loaded. There is net lib.dll from the same temp directory. This doesn't look like a standard. I think this is a legitimate one. Let's see. Let's capture a memory dump of this process for further analysis. We can use pro-dump for that. Great idea. So you can simply take a dump by right click and tell him create dump. This is, we can then have a full dump and then analyze it. So this can be done through the graphical interface or through command prompt. If we go further and see create, or so we can do this through command prompt. Capture memory dump of suspicious process. So we need to mark the process. We need to know the process ID. Where is the process ID from this location? So we can see the process ID. Where is the process? This is the PID. So we can through it tell it to create a dump from this process ID. So this is good. We can tell him to create from this process ID. Create a full memory dump of this process of a specific process name. So you can give him the name or the PID, okay, or the process ID. Capture memory dump with the process memory, thread and handle information. So just wait for a moment, guys. I need to go to do something. So here, let's see the script. It will make a dump from the process with the thread and the handle. So here's some notes. Capture memory dump of process when it makes an outbound network connection. Requires process monitor in conjunction with proc dump. Configure process monitor to filter for the specific process. We have seen process monitor, I think, in previous video how we can do that and capture data. Add filter to only show TCP/IP send receive operations. All of this will be done using the process monitor. Set a process monitor to trigger prodump when an event is matched. In process monitor option, actions, configure actions, run proc dump MA, the ID of the process, network activity dump. Very, very good. You can initialize a dump during the capture process of data by the process monitor. Create a dump of all instances of a process that match a particular pattern using PowerShell. So this is done. So he will do this using sysinternal suite or using process or using PowerShell. So this will be done. Here you go. We'll use proc dump. Okay, to this one. Okay, I think I will do something here. First of all, this is the process extract strings for a dump file for quick analysis. Strings, so and so. Analyze dump with PowerShell script. This example looks for potential encoded commands, so and so. Extract strings from the dump. Look for potential encoded PowerShell commands. Okay, and then save results to a file. Simple command to search for encoded commands in a running process without memory creating a dump. Let's continue dump memory process. Clean up temporary files. So this creates a memory dump of suspicious process. So we will do this remotely. But what about this? He will run remotely on the machine. So you will take this and run it there. So this is a script. Prodump commands for memory analysis. So no, this is not a script. These are this will run, I think, one by one. So for example, he's running the first line. He will do that from. So he will take the first line and run it. I think here you go. This is how he will do this. So prodump. Okay, let me take this also and tell Grok to explaining in layman terms. Let's go and also tell him explain Okay, this script in layman's terms, and let's see also how this will do, or he will do that. Let's see. So until he finish, now he is taking a pros or a dump using proc dump. Now let's copy dump file back to our analyzation. So he'll take a dump and then copy it back to his PC. While that's copying, let's check for persistent mechanism using autoruns. So he's doing step by step. Uh, he will go to autorun to discover persistence mechanisms. So Theo runs autorun on the remote machine, so and so. Uh, this is accept the user license agreement for this program. Then he will copy the program to the remote machine temporarily, and he can bypass user account control mechanism. He will run it under system account, and he will, I think, -a, this will get the auto-run programs. They are exported to a CSV file. So I think this is the case. Then he copies the result back into his machine. So this is it. Then he opens CSV file and apply filters to narrow the results. Okay. Before going further, let's see what Grok has to say about this script. So let's go and see what this will do exactly. Something went wrong. What is something went wrong? Okay. Let's see what this will do. Let me explain script in simple terms. Everyday terms. Imagine your computer is like a busy office and the programs running on it's like an employee working at their desk. Sometimes you suspect one of these employees, a program might be up to something sneaky, like sending secret messages or hiding bad instructions. This is like a detective tool that helps you take a closer look at these programs are doing by peeking into their thoughts, their memory. Is saying that thoughts are like memory and checking for clues. Here is how it works step by step. Taking a snapshot of a program thoughts. Script is a tool called ProDump to take a capture or a picture called the memory dump of what the program is doing at a specific moment. This snapshot captures everything in the program's memory, like notes, instructions, secrets it might be hiding. There are a few ways it does this. By number, by PID. If you know the program's ID number, like an employee badge number, you can tell ProDump to take a to snap a photo of this specific program. For example, this is the PID of the suspicious program. This takes a full memory snapshot of the program with ID, so and so, and save it to a dump file. By name, if you do not know the ID, but you know the program name like svhost, you can take a snap photo of it with the name. This grabs memory of the program called so, with extra details. Sometimes you want more than just a basic photo. This command adds extra info like what the program is touching or working on. So that's good. Here you go. MP part makes a super detailed snapshot. Setting a trap for a sneaky behavior. If you want to catch a program right when it tries to talk to someone outside, like sending a message over the internet, you can use another tool called Process Monitor, Procmon with ProcDump to set a trap. Tell Procmon to watch a specific program. Set it to notice when the program tries to send or receive something over the network. When it does, Procmon triggers ProcDump to take a snapshot instantly, saving it as something like network activity dump. It's like catching an employee passing a note to someone outside the office. Checking multiple programs at once. Sometimes there are a lot of programs with the same name, and you are only care about the suspicious one. This script uses PowerShell, a way to give commands to your computer to find and snapshot them. So we can use both the PowerShell and the program. So here you go, this is the script. This looks at every SV host program. It checks if they are started from a weird place like temp folder, which is might be a red flag. Sys SV host runs from system 32 or Windows system 32. So if it's run from temp, this is suspicious. If they were, it takes a snapshot of each one and names the file with their ID. For example, suspicious SV host, the PID of the SV host process, and dump. Digging for clues in the snapshot. Once you have the memory snapshot, you need to see what's inside. The script uses a tool called strings to pull out readable words like web addresses, passwords, and commands. Very, very good. We can see here that it will analyze the dump for simple words or readable words like web addresses, passwords, or commands. These grab all readable text from the snapshot. It searches for juicy words like HTTP or websites or password and save them to a file called extracted string for you to look at. Hunting for secret codes. Bad guys often hide their instruction in secret codes like encoded command called encoded commands to trick the computer into doing something nasty. This script looks for these by pulling out the text from a snapshot, strings again, checking for specific code patterns that are common in sneaky attacks, like these are the encoded patterns for sneaky attacks. These are bits of code that might mean run this or start this in a hidden way. Okay, if it finds any matches, it saves them to encoded commands text so you can investigate. Okay, all in handy, a handy all-in-one search tool. This script includes a ready-made tool, a PowerShell function, search process memory for encoded command. That does everything automatically. So this is another thing in the script. What it will do, you give it the program ID, it takes a temporary snapshot, looks for the secret codes until it finds anything suspicious. So I think the whole script, or this is the function of the script, you give him some instructions to do, and this is done through this function. It finds anything suspicious in yellow text if it does, green if it doesn't. Then it deletes the temporary file so your computer can stay tidy. Example, so and so. What is cool? Why this is so cool? Think of your computer acting funny like it had been taken over by a sneaky spy. This script helps you snapshot a photo, what suspicious program you're thinking, set traps to catch it, doing bad things like talking to the internet, find clues like secret codes or hidden messages in its memory, automate the detective work so you do not have to dig through everything by hand. So that's the script. If we go and continue from where we have stopped, now we are working with the auto run. So now he is filtering the auto run and see if there is any persistent mechanism for this. So we have already identified a program communicating with an external IP address, so we need to see if this program has an auto run feature in the Windows. So we can see, look at this schedule task called Windows Update Manager that runs a PowerShell script from that same temp directory, okay, where this suspicious program resides. And is scheduled to run at 2 a.m. So how, if we deleted this from the temp file, it will, I think, recreate it. Let's see if this is the case. That matches the pattern of suspicious login perfectly. Looks at what the script does. So again, that matches the pattern of the suspicious login perfectly. So this program maybe it logs in at this, or it runs at the same time as the suspicious login of the accounting users. Okay, let's look at what that script does. Theo copies the PowerShell script from the remote machine and open it in its text editor. It is heavily obfuscated, it's not clear. But I can see it's using Windows Credential Manager API to extract stored credentials. Then it uses those to authenticate to various internal systems. So it's stealing credentials from Angelica Workstation from the Windows Credential Manager and using them to access other systems, which explains the users the authentication alerts I have been seeing. So he is hacking the users with an indirect way. He already put a program on the infected machine, and then through it he connected to the Windows Credential Manager and taking the passwords of the users on this machine and begin logging with them and using it for his malicious activity. Theo exactly and here at the end it's beckoning out to the same IP address we saw in the network connection, properly sending the harvested credentials. Okay, so it's taking the IP, the credentials, and sending out it to the external IP address. We found our initial access point, but we need to understand how this malware got into Angelica system in the first place and what else it might have done. So this is also another good question. Let's use process monitor to capture real-time system activity and see if we can trigger any suspicious behavior. So tracking malware behavior with process monitor. Theo copies process monitor into the remote system and start it with filtering for the suspicious process. So he will run this procmon quite minimized. So okay, so he will run it silently and minimized. So I think there is no user interface will appear because it's quiet and minimized. He connects to the process monitor instance and set up filters. I think okay, I think you need to open it. I will filter to only show an activity for that suspicious SV ghost process and each child process. Okay, so this can be done actually. 3 configures the filters in the process monitor. We have seen this before. I have shown you guys how you can use this process monitor when I was talking about SFC and DISM utilities used to repair Windows. We have used process monitor to capture the process of the SFC and DISM repair, and we have seen how we can filter the process monitor to only watch for SFC and DISM activity. Now let's try to trigger some activity. If we terminate that process, the malicious process, it might attempt to restart itself through its persistence mechanism. If we try to end it, the scheduled task will run it again. So let's see. The use process monitor to terminate suspicious behavior. Watch process monitor display look. As soon as we killed it, there is a flurry of activity. It's reading from that PowerShell script in the temp folder. Now it's accessing the registry. Okay, so let's continue. Let's see. Scrolling out the logs, it's reading from scheduled task we found. Okay, then respawning a new instance of itself. Classic resilience behavior for malware. And look at these file accesses. It's touching Angelica browser profile directories. And it might be stealing browser saved passwords too. Let's capture all this process monitor for further analysis. Okay, so see you save the process monitor log to a file and copy it back to his investigation machine. Now we look a good picture of what this malware is doing on Angelica machine, but we should also check if it is spreading to other systems. Elera, let's use PS logged on to see what other systems Angelica credentials had been used to access. So he used another utility called PS logged on to see what other systems Angelica credentials have been used. So he can take Angelica username and password and access it on other machines other than the infected machine. So let's see this script. This is help us identify potential lateral movement in the network by checking login events across multiple systems, suspicious process creation, remote service installation, file print shares. So this is script. So this we run this script on the other machines to see. So we'll have it as PS1 or a PowerShell script, and then run it. The compromise machine, we can run it on other machines. Compromise machine and suspicious user Angelica.so. So this is it. He is running on the same machine, but we can run it on other machines. The script runs use several suspicious, so pointing at the result looks at suspicious logins, the 3 servers, the file server, the accounting application, and one of our database servers, all happening in the early morning hours, just like the pattern I noticed. So pointing at the result, look at that. Suspicious login to 3 servers, the file server, the accounting application, one of our database servers. And here is the evidence PowerShell remoting being used on the file server. The malware is definitely spreading. So let me take also this one and ask Grok to explain it also in simple terms. Let's go like this. Explain this script in layman's terms. And let's see how this will go. Let's see this. So let's see the answer, how you'll explain this script. Okay, so imagine a computer network is like a big office building with lots of rooms, computers. Sometimes a sneaky intruder like a hacker might break into one room and try to move to other rooms to steal valuable stuff or cause trouble. This sneaky movement between rooms is called lateral movement. This script is like a smart security guard that checks for signs of this sneaky behavior across the network. He does step by step in plain language what you want to tell the script. When you run the script, you give it some basic info to start its investigation. Which computer you might have been broken into, you have to tell him this. Which user account looks suspicious, you have to tell this him too. What other computers? To check optional, if you do not say, it picks important ones like the main security disk or storage rooms. So if I did tell him a computer to investigate, he will take the file server, the domain controller, other important uh, computers to check. How far back to look? We need to look for 7 days, for example. Where to save the report? Okay, so these are all parameters to use with the PowerShell script. The script starts by making a folder on your computer to store all the clues it finds. Think of it as a security guard office where evidence gets organized. If you didn't specify list specific computers to check, it picks some important ones to investigate. Domain controllers, they are like the main security desks that control access. High value targets like the storage room, file storage room, or app control centers. It has a default list like file server and app server, plus the computer you said it might be compromised. So, okay. Then it tells you, hey, I'm checking these computers and lists them out. Step 2, look for clues. The script asks a detective and searches for 3 main types of clues on each computer. Login events. Check the security logs to see if the suspicious user logged in, especially in a sneaky way, like remote desktop, controlling computer from far away, like using a remote control, net logins, accessing shared files or printers. Also looks for times where someone used special passwords or credentials, which might mean that they are using stolen keys. Suspicious processes. It looks for programs called processes that hackers often use to move around or cause trouble, like psexec, WMIC, PowerShell, tools to run commands on other computers, Mimikaz, a tool that steals password, net commands used to explore the network or check accounts. If they spot those running in a weird way, it flags them as suspicious. Service installations. What's have been added? If checked in a new background task called services are added recently, hackers sometimes install them to stay in control or run sneaky programs automatically. For each computer, it gathers these clues and keep them in lists. Then we have the write the report. After checking all the computers, the script organizes everything it's found. It saved the clues in the spreadsheets, one for login events, one for suspicious processes, and another for service installations. You can open these later to dig into details. It also writes a summary report, gives you the big picture, how many special login processes and services installation it's found, which computer have these clues, tips like check computers with a lot of weird stuff going on, see if other clues happen around the time of the break-in, look for odd services names or file paths, checking who's there right now. The script uses a tool called PS-Login from Sysinternals to see who is currently logged in into the compromised computer, like peeking into the room to see if the suspicious user is still sitting there. If it can't find the tool in your computer, it tries to grab it online, which is good. Now we have the wrapping up. When it's done, the script says all finished. I have saved their folder location. Take a look. What this all means. Think of script a security guard patrolling to the office building. It's checking who has been in which rooms, login events, what tools they might be used to sneak around, special process, what might have been left to come later, service installations. So let me have something here. We have PS logged in. I know this program. So this is on my chain. Let me try to put it on a CMD and let's see what is the output. Just didn't use it for let's try to see this. If I can ps login.exe and see this. Okay, so no one is logged in via resource. So no one knows accessing the shared resources, but the one logged in locally, it is me. Okay, this is the machine and this is me, and via resource share. So this is a good utility. Okay, we can leave it. Now we can return to the case. So this is the script, and we have partial remoting of the malware is for different spread. We need to check those system too. Let's use Sigma to quickly scan them for scan them for indicators. We have already uh, what is a Sigma? Sigma rules. What are Sigma rules? So title, description. So I think this is maybe like so this is like maybe a documentation. Let me see. What are Sigma rules? So let me see. PowerShell script. Okay, let me. I need to know what is the Sigma rule. Okay, let's use Sigma to quickly find. Let's see what Sigma means. Okay. We need to check those system tools. Let's use Sigma to quickly scan for indicators. What are, okay, let me check. Okay, I can take the code itself and let's see, explain. I take it to Grok again, explain this script in layman terms. And what is Sigma rules? Let's see how this will do. So now use this script to do something, maybe run this custom Sigma rules against the file server and the accounting department. So he will take a couple of this program or this script, the previous script we run on the other servers to check for infection. But first, let's see Grok and what he has to say about this. So let me see what he is talking about. Now we can go and see what this script do exactly. Now let's go and read what does it do exactly. Okay, let's break it down simple. Imagine your computer is like a house and hackers are sneakily intruding and hackers are sneaky intruders trying to break in. The PowerShell script and Sigma rules work together like a smart security guard with a checklist to spot signs of trouble and report them back to you. Here is to do step by step. What are Sigma rules? Sigma rules are like universal cheat sheet for catching hackers' tricks. They are instructions that tell security tools What suspicious activity looks like, things hackers might do to mess up with your computer. These rules are written in a standard way, so many different tools can use them, like a kind of how a recipe can be used by any chef. In this case, the Sigma rules are designed to spot specific hacker behaviors seen in a known malware attack on a computer, so and so. For example, Sigma rules look for suspicious service installation. A hacker might sneakily install a service, a background task, to keep coming back. The rule flags services with weird names like svghost.exe or one installed from a temp folder, which legitimate programs don't usually use. Suspicious PowerShell commands. PowerShell is a tool for giving commands to Windows, but hackers use it to steal stuff. The rule catches commands that are hidden, encoded, and try to grab passwords or download bad files. Suspicious processes. These are programs running on your computer. The rule spots fake ones pretending to be normal, like svghost.exe or PowerShell commands that look sneaky. Each rule has details like what to look for, specific rules in the computer logs, event 7045, what it matters. Why it matters might mean a hacker is trying to stick around or take control. False alarm. Sometimes legitimate stuff looks suspicious, but it's rare. What does the script do? The script called the script called invoke Sigma rules. It's like a detective that uses these Sigma rules to check a specific computer, this server, for a signs of break-in. It's written in PowerShell, which is a way to boss Windows around. Here is how it works in plain English. Get started. You tell the computer to check and where to save the results. Okay. It looks for a certain number of days. Looking for clues. The script check three big things based on the Sigma rules. Suspicious services. Digs into the computer system log to find services installed recently that match the rule from temp or svghost, the Sigma rules. Okay. Suspicious PowerShell activity. It checks the PowerShell log for sneaky commands, like ones that are encoded and try to steal password or download stuff. Suspicious process. It looks at the security log for programs that seem off, like a fake svghost or PowerShell running hidden commands. Saving the evidence. If it finds anything suspicious, saves the details like what happened and what it was in a spreadsheet. Suspicious services, suspicious PowerShell, suspicious processes. Writing a report. Okay. How many? So this is a report. Wrapping up. It tells you where to find the report on spreadsheet and give you a quick yes or no whether the computer seemed hacked. A real example. So let's say you run the script like this. Invoke Sigma rules. This is the computer and this is the result. If it finds two weird services and one sneaky PowerShell command, the report might see so and so, this system signs of compromisation. If say alerts so and so have to be compromised in red. If find nothing, it stay, everything goes okay. Why does it matters? Think of it as your personal security guard. Sigma rules are the brains knowing what hackers tricks to look for. The script is at the hand doing the work by checking the computers and reporting back. So these are rules, and the script are applying these rules. Together they spot something like a hacker sneaking through a fake service, something using PowerShell to steal your passwords, a program pretending to be normal but doing abnormal things. So this, for example, here is the Sigma rules. Strange. This is the first time I see something like that called Sigma rules. It is arranged in a certain way. Then to apply Sigma rules. So here I will take the Sigma rules. Okay. I don't know if this. Okay. Anyway, this seems to be a new info for me. But anyway, let's continue with the case. So now we have run it on the file server, and let's see what is the case now. We have the script completely display the result. Examining the result, the file server definitely shows signs of compromise. It has both suspicious service installation and PowerShell activity matching our rules, but the app server looks clean. It seems that the malware tried to move laterally but wasn't successful there, maybe to different security controls. Based on our findings, we need to quarantine both Angelica workstation and the file server for further investigation. The compromised accounts need password reset, and we should check for additional affected systems. Let's use sysmon to monitor for similar activity across the network. I will create a custom sysmon configuration based on what we have found. So this is also another way for logging suspicious activity through the sysmon utility. This prepares a custom sysmon configuration based on the discoveries. Let's see this one. So this is uh, a sysmon XML file. So we will run the sysmon program and provide this configuration as an XML file to watch for certain activity or to log certain activity. So I can take also this one, copy, and see what it will say. I've created custom sets specially tailored to detect this kind of threat. Let's deploy to the entire accounting department to monitor for similar activity. First, let's go to Grok again, explain this XML file content in layman terms. Okay, so we can go like this and put like that, and let's see how this will go. Until he finishes, we will, so we should create a schedule task to regularly scan for these indicators. So he will have a schedule task to run the sysmon with this configuration, or to search for certain processes or certain pattern. We also use procmon to create memory dumps of suspicious processes on the file server for deeper analysis. So run procmon on the file server to capture memory dumps of suspicious processes. We need to implement contaminated measures. I'll use psexec to stop the malicious services and remove the schedule task. So this is good. He will run it, remove the schedule task on the infected machines, stop. So he will remove this one and stop the malicious, or this will delete the schedule task. He will stop the services or the service manager and then delete. Let's see here, he will delete the task and stop. Why he's doing that? This delete the schedule task from the affected machine and then net stop SV host. I think this is the service. Yes, this is the infected service. He will stop it and he will delete the schedule task from file server and the affected machine. We can also check, also block outbound connection to that command and control IP address while we continue the investigation. So also we need to block the external IP address. Elera calls the network team to implement a firewall block to block to the external IP address. Just wait for a moment, guys. Just wait for a moment. So let's continue, guys. Here is the analyzation of Grok for the XML file for the sysmon application. Alright, let's break down this XML in simple everyday language. This is a file is a configuration for sysmon, a tool that acts like a super watchful security guard for your Windows computer. It keeps an eye on all sorts of activities to spot anything fishy, like a hacker or mirror trying to cause trouble. Think of it as setting up a bunch of motion detectors or motion sensors and cameras around your PC to catch suspicious behavior. Here is what this configuration tells sysmon to do, step by step in plain terms. At the top, there are a couple of key instructions on sysmon. Capture all hash. It's like telling sysmon to take a unique fingerprint of every file it sees. These fingerprints, called hashes, help figure out if a file is safe or something nasty, like a known virus. So he's checking the hash of the files to know if it is a legitimate file or a suspicious file. Check digital signature. Sysmon checks if files have a legitimate stamp of approval from their creators. A digital signature, it's like verifying an ID to make sure a file isn't fake or tampered with. Then we have event filtering. What to watch for. The main chunk of this file is the event filtering option. This is where you tell sysmon exactly what kinds of activities to keep a log of. It is set to include specific events, meaning it only records stuff that matches these rules. Let's go through each type of event it is monitoring. Process creation. What it does, logs every time a new program starts running on your computer. Why? It's to capture everything by default. So you got a record of every app or process that kicks off, like catching every car that drives into your neighborhood. File creation time changes. What it does, watches for when someone changes the timestamp on a file, like when it was created or modified. Why? Hackers sometimes tweak this timestamp to hide their tracks, a trick called times stomping. This logs in when this happens. Network connections. What does, keeps track of certain internet connections your computer makes, like connection to specific IP address, monitoring this IP address, probably a known bad guy like a hacker control server room, connections to port 443, 8443, and 4443. These are popular with hackers for sneaky communication. Connections from suspicious programs, like one running from the temp folder or named PowerShell exe or SV host, but it ignores the legitimate SV host in system32 folder. This is very, very important because SV host is a legitimate file, but its location in system32. So if it's in another folder, then this is not a legitimate file. Why? This catches your computer phoning home to a hacker or using shady channels. So all of these are what this sysmon will do. Process termination. What it does, logs when security programs with names naming containing defender, antivirus, or security gets shut down. So he's monitoring when an antivirus got shut down. Why? If something kills your antivirus, it might be malware trying to turn off your defenses. Image load DLLs. What it does, tracks when certain DLL files, helper file program uses, get loaded, especially ones from the temp folder or named netlib.dll, suspicious spots or names, unassigned DLLs, not legitimate step, loaded by critical system stuff like svhost, winlogin, or lsass.exe. So that's good. Hackers often sneak bad DLL into your system, so this flags anything sketchy. Number 6, create remote thread. What it does, logs when a program injects code into another program. This is common hacking track to take control of legitimate process, so it is set to catch everything there. Logs when one program injects code into another program. Raw access read. What it does, watches for programs reading data straight from the disk, skipping normal access. Okay. Why? This could be a way to steal info like passwords, so it logs all these by default. Registry event. What it does, monitors change specific parts of the Windows registry, a big setting database. This is the definition of Windows registry. A big database. Big setting database. Places that control what runs your computer starts, current version, run, or services. I think this is the auto start programs. Spot malware often used to stick there. Task cache or winlogin. So I think this is the auto run maybe programs, but from the registry. Hackers. Why hackers tweak the registry to make their stuff run automatically? This is it. This catches that. File create events. What it does, logs when files are made in certain places or types, like suspicious spots, temp, app data folders, script file ending in ps1, vbs.bad.cmd, executable ending in .exe.dll.sys. Why? Malware often drop files in these places to run sneakily in the temp folder or app add. These are put in these two locations uh, most of the time. Pipe events. What it does, track the creation of name pipes, ways programs talk to each other with names like ISARPC, SAMR, NetLogin, Mojo. Uh, Malware uses these pipes to communicate or control things, so this flags them. Okay, so this seems to be good. 11. WMI events. What it does, watches for activity in Windows Management Restaurant. Why? Hackers use WMI to run code or stick around, so it logs everything here by default. DNS query. What it does, monitors internet domain name lookups. Why? No specific bad domains are listed yet, but you could add them, evil.com, to catch suspicious lookups. Okay, to see if the DNS contains suspicious websites to be resolved. Process access. What it does, watches for programs trying to mess with LASSS, where passwords and sensitive stuff live, but ignores legitimate access from security tools or CSRSS. Ignoring Windows getting to this less, but suspicious access to this one, maybe it is a try to get the password. Clipboard change. What it does, logs when sometimes changes or what's sometimes changes what is in your clipboard, what you copy and paste. Malware might snatch passwords or data you copy, so this keeps an eye out on the copy and paste. The big picture. This one configuration is like a high-tech security system for your computer. It's watching for all sorts of red flags, weird network connections, sneaky file changes, program shutting down your defenses, or attempts to steal sensitive info like password. By logging all these events, it creates a detailed record you can check later to spot trouble, like reviewing security cameras footage after something suspicious happened. It's all about catching the bad guy in acts. How to run this XML with sysmon. Give me the syntax. Okay, let's see. So here is the syntax how we can run this utility with this configuration. So here you go. This is, let's see here. So you have the file named sysmon configure XML. It's located in ccoms. You can run -c. So it will copy the configuration and run it. Okay, so I think -c, this is related to running this configuration maybe. Okay, alternative privileges. So here you go. If it's not installed, we need to install it first. Apply the configuration installation with this syntax. Okay, -c option is to update the configuration is likely what you need, assuming sysmon is already present. Okay, so this is already, we have already it is already installed. So -c just to apply the XML configuration, and all of the things will be logged in application and services logs, Microsoft Windows Sysmon operational. Okay, this is how you can use it. Anyway, so we return to the last thing. Now we have Elera and Theo. You need to have to develop a redemption plan. This includes cleaning the infected systems, resetting password for all affected accounts, investigating how the initial infection occurred, updating security controls to prevent similar infections in future. So let's also deploy our custom sysmon configuration to all systems. It will give us better visibility for both this incident and future incidents. So this is good. Identifying patient 0, who is the source of the infection. It is Angelica PC or another one. 3 days later, Theo and Elera are in a conference room with laptops and evidence board. They contained the immediate threat, but are now investigating how the malware initially entered the network. So we have cleared the malware from Angelica workstation and the file server, and we have reset passwords for all affected accounts, but we still don't know how the malware get it initially. Let's look at the timeline we have established. The first suspicious login was 18 days ago, so the initial compromise has to be before that. This is a logical thing. I have been reviewing email logs from Angelica and other affected users. Look at this. Angelica received a PDF invoice from what appeared to be a regular vendor 19 days ago, but the email actually came from a look-alike domain. Okay, let's check if she opened it. We can use sig check to verify if an unusual executables appear on her system around that time. So let's see what he's talking about here. He's talking about running syscheck minus s minus h. This is to bypass user account control minus c, I think, minus ct minus d, and Zelic Smith. What this do exactly? Here is something interesting. The file called invoice viewer.exe in her downloads folder from exactly 19 days ago. It is unassigned and has a suspicious hash. Let me see first what does this line do exactly. Let me tell Grok explain this command line in layman terms. Let's put it and see how this will be explained. So let's break it down. First, one query left. So, okay, let's see here. It's like a detective. So this is the program. Minus S tells Magic to dig deep. Minus S. Okay. Just look at the files in one folder, but also look in all subfolders. Minus H to figure out each file's unique fingerprint called a hash. A hash is like a DNA code for a file. If the file changes, the hash changes too. If a way to spot if something had been messed with. Minus C, this makes the output easy to use in a spreadsheet like Excel and pulls out into a comma CSV file. Okay, minus CT, this adds a timestamp to the report showing when each file was first created on the computer, like date of birth for the file. Minus D, Angelica, this tells check this where to look. In this case, it's the folder so and so, which is probably the personal folder for the user named Angelica. Think of it as telling the detective, go investigate everything in Angelica desk. Okay, so minus L19, this part says to save all findings in a file called 19 days. Like telling the detective to write the report and name the report book 19 days. Note 19 days is an unusual name for a file. It might be a typo or placeholder, but as written, that's what it does. Okay, so what does this do? Explore here in plain text, the command still explore everything in Angelica folder. Check trustworthy, see if each file has a valid digital signature to confirm it's from a trusted source. Get fingerprints, calculate a unique hash for each file to help verify if its integrity, if it is tampered with or not. Note creation dates, record when each file was created, make a spreadsheet, name it so and so. The part about minus L is a bit old. Normally, we would expect a log file to have a name like report.txt or so and so. The phrase 19 that might be meant to filter files like look only for since 19 days. I think this is it. He's talking in this, but SIGINT doesn't have an option to do that directly. So as it's written, it just means that the output to be saved 19 days if this is the goal. So let's see sign check. Sign, where is the sign? Let me see the parameter. It is called sign check. Check. .exe, here it is. This is it. Let's go and see the syntax. So minus L, where is minus L? Okay, this is add CT output with a data delimiter. So I think here minus L transfers symbolic links and directory conjunctions. So I think here there is something with this things here. Minus S. Let me see the syntax correctly. Minus S to subdirectories. That's correct. As for minus CT output with tab delimiter. Let's see here. So this is minus S dig deep. Yes, S hash. Let's see. This is show file hash. Yes, correct. As for minus C, this is make it in comma delimiter. As for this CT, add the timestamp to the report showing each file was created first. I think NOS minus CT, this is not correct. Okay, this is CT output with tab delimiter. So this is not correct by Grok. As for minus D, let me see, minus D, dump contents of a catalog file. So this tells where to look. Okay, to minus D, so and so. This is dumping it. Okay. Let's see here, minus D, dump contents of a catalog file. So we have all of these. So for example, we have minus U, minus E, minus so and so. So anyway, this is the file and this is the prompt. So we have minus S, minus H, hash C, CTT, minus D, minus L, 19 days. Let's minus L saying traverse symbolic links and directory conjunction. Where is minus L here? Minus L. So I can't see something called minus L. Minus L. This seems to be here is minus L. So where is minus L? This is I. Show catalog names and signs. Minus L. Traverse symbolic links and directory conjunctions. I don't think I know what this means. But anyway, this seems to be a valid answer. So if we can continue with the report, so it will check anything related to this profile or the user's profile. The file called so and so downloads, it's active for 19 days, it's unsigned, and it has a suspicious hash. Let's submit that to VirusTotal. This is through Process Monitor. You can visit the website VirusTotal. Error submits the hash and reviews the results. It's definitely a malware. Multiple engines detect it as a downloadable Trojan. This might be our initial infection vector. So the attack chain was phishing mail with a malicious PDF attachment. The PDF contained a link to download invoice viewer.exe. That downloader installed the presented malware as a service and scheduled task. The malware stored credentials for Angelica Workstation. Used those credentials to move literally to the file server. From there, it continued to harvest credentials and access sensitive systems. That matches with everything we found. Looks we have solved this case. Reporting and enhancing security. So to summarize, we identified the credential stealing malware that has infected 2 systems and compromised 3 user accounts. The initial infection vector was a phishing mail targeting the accounting department. We have contained and remediate the immediate threat, but we recommend implementing several security enhancements to prevent similar incident in the future. Theo brings up a slide with a recommendation. First, we should deploy our custom sysmon configuration company-wide so to monitor this kind of events. This will give us much better visibility into suspicious activity. Second, we need to enhance mail filtering to catch spoofed domains like the one used in this attack. There is a way to do that through Office 365, a guaranteed way, by the way. Third, application whitelisting would prevent the malicious executable from running in the first place. Okay, app control or app, there is something called app in Windows called something called app locker. You can use it to prevent running programs that are malicious, or to run a certain programs, a list of programs to run, and others are blocked. And finally, regular security awareness training for employees. This is good and very valid point and very critical point. Awareness training for employees with a focus on identifying phishing attempts, especially for departments like accounting, which deal with financial transactions. Excellent work, CISO. Both of you are impressed how you use the Sysinternals tool to investigate and resolve this incident. Let's implement these recommendations immediately. Scene 10, 1 month later, testing the new security control. Theo and Rela are in this SOC reviewing the new security dashboard that integrates Sysmon data. The new monitoring setup has already paid off. We caught 2 phishing attempts last week before anyone even clicked on them. Look at this, the process monitor and auto runs alerts are integrated into our SIM. We have much better visibility across the entire network. Graining, now we should do a red team exercise to test these new controls properly. I have worked on a simulated attack that mimics the techniques from the last month's incident, so you need to try to see if their precautions or their controls will help us to prevent such incident. I like the idea. We can use these internal tools both to conduct the test and to detect it. Be a great way to verify our defenses and train the SOC team. So here, this is the end of the case, and here how we can make a virtual lab to exercise this. So, for example, here is the setup of the lab environment, and here we can see create a malicious process, the scripts and everything. I think this is a very good thing. You can take it all and try to use it. Let me try to see if I can export this. I tried later, but let me try to see. So this is a third case. I will use it, or I will try to discuss it later, but let me try to see if I can export this whole case in a markdown file and give it to you guys, but let's wait and see. So with God will, in the upcoming video we'll try to see the last case. So he is saying you have exceeded the limit for this message, so I cannot export it, unfortunately, but we can do something much better. Here, let me go to the case. Okay, I will just close this one, and I'll try to let me go and see the case there. Let me show you the case itself. So this is the upcoming case. Okay, as for the other, or the case that we were talking about, I'll try to export it in a way. So this is how we can do this. I will try to take it and put it in a text file and give it to you guys and see if we can simulate this whole case. Sorry for the long time. I'll try to export it and put it in my Telegram channel. Hope this video is informative to you all, and thank you all for viewing. The Telegram channel is IT Visualizer. Thank you so much.